All right, data flow diagram. Everybody understand what they are at this point?
Isn't it like when making a visual representation of a process?
Well, yes and no. Visualizing how data comes in and out of a system, right? So information is gathering in a variety of ways. Again, it could be swiping a membership card. It could be processing a transaction. It could be someone at a counter entering member information if they've become a new member. And output would be what the system spits out. A lot of times that's like reporting, accounts receivable if they're going to like an accounting program or the accounting module. So again, input coming in, output spitting out. And data flow is about visualizing how that all happens and also visualizing from what entities your data is coming from, like if you're reaching out to a database to get information, and also how that data is flowing not only out of the system entirely, but to different sections of the system, right? So instead of DFDs, data flow diagrams provide a logical model, shows an overall model. It shows what the system does, not how it's going to do it. That's the physical part, right? That's when we get to implementation, or actually taking this logical model and providing it to your programming team who's going to render it in code, okay? What is the point of a smart board? It is not smart.
You tried tapping it?
I tapped it. I've hit it even, and it doesn't work. I'm not that tall. I might fall over. I haven't eaten. I told you this. I might pass out. Yeah, if I ever pass out, just go get me a mint or something. Just cram it in there. All right. Let me get here real quick. Well, that's... All right, what we're talking about are these things, right? Really what this whole PowerPoint is just identifying how you should render your data flow diagram, what the different pieces are, the objects you're going to create, okay? So your rounded edge square here is your process, okay? And your process could be anything. Process could be complete transaction. Process could be create member profile. Process could be what else? Swipe key card. Process could be what? You get the idea what a process is. Something that's initiated that's going to result in something, right? Okay, so smartboard's not smart. Hang on. This is your process symbol, okay? So when you're rendering your models, processes should be rendered as a square with rounded edges. And you can easily do that either using Visio or Microsoft Word. You guys know how to create shapes in Microsoft Word? You all have taken CIS 110, so I'm not going to take time showing you how to do that, okay? So this is your process symbol. Each process must have at least one input and output because none of them are none of them are just kind of hanging out there independently. They're either receiving something or they're doing something in order to operate and be part of an interoperable piece of the system. Okay, they contain business logic, meaning that when they take the data, they're doing something with it before they send it to another module or export it completely. The number, right, when we get down to looking at the context diagram, a lot of times you'll see a number here. It doesn't really mean a whole lot of anything. You're not really prioritizing them in any particular way. It's just a way to be able to reference them. Okay, remember when you did your the little tables that corresponded to your process diagrams and they had an ID number? It wasn't really a way of prioritizing them in any way, just a way of identifying them. Okay. So your data flow or your processes are going to be indicated by your rounded edge squares. Data flow symbols are obviously your very simple arrows, okay? So a symbol for a data flow is a line with a single or double head. It can just be a single, okay? So in this case, hours worked and pay rate goes in to the calculate gross process, right? Logic happens, and then what happens? Their gross pay is spit out. And it's probably sent to another module, right? It generates their paycheck, a pay stub, right? A deposit to an account. Exactly, yes. So this is just a single process, okay, with inputs and outputs, but you can see how that single process would have to be a part of a larger process and a larger data flow in order for it to make sense. It doesn't live in isolation, right? Okay, yes? Yeah, okay. Say that again?
We would have to model every single one of those?
You'll see, yes. Yes and no, I'll show you. I'll show you. Okay. Inconsistencies meaning that they require input. There's no input here. Apply insurance premium, there's just output, right? You're not putting anything in to be processed to output anything. So if you're identifying a process, make sure that you have input, not just output. Same thing here, you've got input coming in, but this is a process, nothing's being spit out. Date of birth, calculate grade, final grade. Why does that not make sense? Exactly. Okay, so when you're documenting the data that's being ingested, make sure that it's relevant to the logic that's going to take place to output data on the other side. Okay, so that's why these are indicated as incorrect. These are just really good examples of how you require input, you require output, and you need to make sure that the data being input is what's required for the process to be effective. Okay? Here's your data store symbol. All right, what are some examples of data stores? Database? Yeah? What else? Mm-hmm.
From your last diagram, your content, hours work.
Mm-hmm. Mm-hmm. Okay, so as you can see here, it's not necessarily specifically identified database located here, just that patients is a data store, and from that you're going to get information like symptoms, which is going to go to a process to diagnose patients, right? There'll be a separate module for that. There's a module for treat patients. You're going to be outputting treatment information, which is going to go back into that data store. Think of a database, a record, right? A patient record, which is going to indicate all of their occurrences or medical visits. For every medical visit, there's going to be information documented, which is pertaining to their diagnoses and their treatment, right? So the doctor's going to document that in their file, and then it's going to be appended to their record in a database, right? Okay, so each of these, the squares with no rounded edges, refer to a data store, okay? Or something or somewhere that your process is going to retrieve data from. Okay, so a patient database, accounts receivable, daily payments. We're not necessarily interested in where that lives, the details of what's included there, just what that data store is all about and what kind of information you're gathering. We're going to talk about what the data dictionary is. You guys aren't going to have to mess with the data dictionary, but the details are documented in the data dictionary, okay? The process models are just kind of a bird's eye view or a logical model of the system. The details are what's appended to the data dictionary at the very end, which would be included in your entire requirements document. Entity systems, how it interfaces with the outer world. All right. Again, square box, little black edge around them. You can do that with like a shadow effect in Microsoft Word. But again, examples of external entities that are going to be connected via a process. So perhaps you are receiving a customer list that you're having to import, okay? MARC records, my example from a library database. You're having to reach out to another data store to import data. It's not that you're necessarily moving data throughout your individual system. You're reaching out to an external entity to get it in before you're doing something with it. All right. Okay, so your first task, task 1, is to draw a context diagram. All right, so pretty simple. Bird's eye view, top level view. Includes the system itself. So what would this be? For your, the TIMS, yes. This would be the TIMS, okay? And these would be your external entities, right? And the basic data flows. So no, at this point you don't really have to get down into the weeds. This is just a bird's eye view, okay, of the TIMS system, and then the entities that you imagine that it's going to get data from, and then how that life cycle is going to happen. Again, you don't have to detail the frequency of it, okay? Just in general, what the inputs and outputs are to those external entities to the TIMS system, okay? Does that make sense? Okay. And really, you could even really use this here as a really good basis, okay? Because are they going to have customers? Yes. Are they going to work with a bank? Yes. Accounting? Yes. A warehouse? Yes. They have retail operations? Exactly. Exactly. Sales rep? Depends on, again, exactly. Exactly. It depends. So if you want to use this model as a really good basis, have at it. This is a really good model to start with. And then based on, again, how you've kind of visualized your system, again, because some people have gone like the extra mile in sort of imagining what it could look like. But if you've sort of done, kind of kept it simple, keep it simple, Sally, then this is a really good place to start, okay? Because a lot of this is going to be relevant. Yeah, I bet. But does that make sense to everyone? Just kind of a bird's eye view of your system, your TIM system, and the different clients, if you will, that it's working with to ingest data and how that sort of life cycle of data is happening. Okay? So again, this is in the PowerPoint, which is included in Blackboard this week, and this is a really good model for you guys to work with for your task 1. Bird's eye view, top level view, your context diagram. That works. I could do that. I can't. I can. But then I'd have to.
Go back.
I can't. Yeah. I could. It's okay. I need to walk anyway. Remember, I don't go to the gym anymore, so I need to walk around. Okay. So if your context diagram is like the really top level, okay, your diagram 0 is the next level of granularity. Now the next level is where you're not going to go. You don't have to do this. All right, the next level is this lower level diagrams where you're like literally getting down at the absolute process level and taking it all the way down to what's called the functional primitives, meaning the nitty-gritty details of what's required for your individual processes to work in practice, okay? Really, that's what the developers would need to bring this product to fruition, but you're not being asked to do that, okay? Really, you're not being paid an exorbitant amount of money to lead this project from start to finish. You're just being asked as a student of this class to kind of conceptualize what it would be like in this role and to kind of take on some of these opportunities for developing diagrams so you get a little bit of practice. So that's why I said yes and no to Jason's question. You are not going to have to flesh out all of your individual processes. What you are going to have to do is your context diagram, which is like your bird's eye view. And again, great place to start right here, okay? Work with what you know is a given for your organization and then add on based on how you've imagined your TIM system will work for personal trainer. All right, and your diagram 0 includes your processes, okay, and your external entities, but it doesn't necessarily get down into the weeds of the individual inputs and outputs of the processes, just how they relate to your overall entities, okay? So again, you could look at this. You could actually, again, because this pertains to the previous diagram, you could use this model as a good starting place and edit it accordingly based on, again, how you have conceptualized that your TIM system would work, okay? So context diagram, bird's eye, very top level view, TIM system in the middle, okay, with your external entities. Here, instead of, and that's why it's called, you've got your 0 there, because this is ground level. Then from here, again, you have your individual processes. Remember that number doesn't really matter, it's sort of just an identifier, if you will. But your individual processes, the inputs and outputs of how they sort of work and liaison with all the external entities and data stores. Okay? Okay. All right.
So account receivable notice wouldn't be linked to accounting?
Apply payment, so the customer creates a payment which goes to the apply payment model. Payment detail is included in the accounts receivable data store. Invoice details go back, which then goes to cash receipts for the end of the day. I'm assuming the way that they've rendered that is that, well, you could totally rework that, yeah. You could move this over and tie it into that accounting data store, but it looks like the way that they're doing it is that this data store, basically you're adding payment details to this database, if you will, which is then outputting an appended record, which is then processed and sent maybe as an end-of-day report to the accounting module in some way. Does that make sense?
Yeah, I should organize a little bit.
Well, and you can. Again, I'm just saying that for those of you that are kind of like, I don't really know a place to start, these are good places to start. But if you were to, you could totally rationalize how this data store would be included over here and could be directly tied in to that accounting entity. Well, that's true. That's true. Well, then, okay, if you wanted to, again, imagine this however you will. If you wanted to do that, then just swap the two so that it's easier to relate to those two external entities and put your sales department over there. And, of course, that may not be sales department, right? But, again, this is a good place to start.
All it's doing is getting a copy of the same invoice that the customer is getting, like, the way that works.
Say that again.
Like the account receivable is just getting a copy of the invoice that the customer is going to see as well.
Yes.
So technically you could move it to a different location.
Yeah, exactly. Yeah, you could move that wherever. And again, depending on where you're going to get your data from, how you're going to store it, and how you imagine your process to work would depend on how you organize this diagram. But again, a good place to start, and you can kind of move your entities and your processes around to suit your individual model. But what you're really doing, again, retaining all your connections. This is a zoomed-in view. I need to touch on something. Retain all connections from process 0, so from your context diagram. Okay, so any relationships that you set up in that original context diagram, when you get down to this next level of granularity, retain those, but just integrate in your processes and any other data stores that you want to include. What you're working toward here, and again, we're not going to get down to this level, is what's called the functional primitive, which is where your processes are completely fleshed out. Okay, all the details are documented in your data dictionary, and your requirements document is ready to be delivered to your development group to then bring this thing to reality, to fruition. All right, your lower level diagrams, again, this will be getting down into the weeds, but we're not going to go there. May be necessary to flesh out all processes to functional primitives, may be rendered individually as DFDs, but again, we're not going to go there. We're not going to make it any more complicated than it needs to be. Like I said, a data dictionary is what's appended, okay, to all of these logical models, and it's going to get down into the weeds of, or the details of, what all these processes are all about, where all of this data is coming from, how it should really work in practice. That's the part that the developers would really use to be able to understand exactly what you mean with that model. So a set of DFDs produces a logical model, but details are documented in the data dictionary. Central storehouse of information defines and describes. Objective, provide clear, comprehensive information about the data and processes that make up the system. Okay? So if the development group, if you will, were looking at those logical models and they had a question, they could refer to the data dictionary to get more information. Now the chapter gets really down into the weeds of documenting various aspects in the data dictionary. Because we're not using a case tool, we're not going to be required to do any of that. But if you're interested in what that looks like, I would refer you to the chapter. Because again, we just don't have time to get into that level of detail in the class. But that's what the data dictionary is all about. If you see that come up in an exam or in one of the quizzes or perhaps on the final exam. Includes things like the data element attributes, data flows, data stores, processes, and entities. Okay, so when you're asked in task 3 and 4, okay, to include what attributes you think might be included for these particular things, these are the kinds of things you might mention. Okay, so for data flows, their name, a description, any alternate name that you're using, origin, meaning where did they come from, data stores, again, name, description, processes, Process description, including inputs, outputs, any logic. We understand what we mean when we say the word logic? Okay, good. Exactly. Or just really at just a general level, you know, data comes in, what do you do with it? Data shoots out, okay? The logic would be what you're doing with it. Again, you don't have to get down to the weeds of like the mathematical equations or processes, but generally what's happening to the data before it's spit out on the other end or passed on to another module in the system. So elements of the data dictionary included here. Again, your chapter, if you want to refer to the chapter in the book, really breaks it down at a real granular level. But task 3 and 4 are going to say, in addition, actually what is, I don't have the book in front of me. It asks you to come up with a minimum of, I think, 5 attributes to include. So I'm going to ask you to, in addition to including the base attributes, okay, yes. What now? Okay, that's what I'm saying here. Like your entity could be customer, okay? Okay, so that's the entity, that's the data store that you're pulling from. The attributes are what describes that entity. So their name, a description of that data store, what the inputs or outputs would be, that kind of thing. So you're going to define what you think the attributes are going to be for that entity, basically a description, okay? What data are you capturing and including to reference to that entity? But what I'm saying is, in addition to just saying, in addition to capturing in your memo, include the name, description, give me an example. There's some screenshots in the book, but give me an example of, for each entry that relates to a process or entity included in your diagram, record the various attributes as if you were documenting them in your own data dictionary. Exactly. 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 And again, you're making it up. Fine to make it up. But what I'm saying is go beyond just thinking, oh, I would give the name, a description, and talk about inputs and outputs. Okay, say that in your memo, but also give me an example of what it would look like if you were capturing that information on that entity or process. Okay? Okay. It's doable. It's totally doable. Process description documents the details of the functional primitives. Again, the devil in the details for what's required to bring this thing to fruition. Breaks the process down into smaller units called modular design. There are a lot of descriptive tools used, structured English, decision tables, decision trees. Again, you're not being asked to do any of this. And I'm not going to spend a whole lot of time on it again because there's a lot here that's easy to get bogged down on. Okay, but what you're doing here with like decision tables and decision trees are doing things like looking at all of the possible conditions and outcomes that could be a part of a system having to make a decision. Okay, you have to really think down into the weeds of what would happen if member swiped card and card was inactive, member was inactive, member account could not be found. You know, there's various things that could happen aside from member swipes card connected to user profile, let them in the door, right? So a decision tree and decision tables are used to try to think about what all of those possibilities could be so that that can be written into the system. So again, you have a system that's flexible and can accommodate the various things that may be thrown at it, okay? Because nothing's going to always work exactly as it should. You're not going to be required to do any of this, but I just wanted to touch on it because it is in the chapter. And various tools are used to break these logical models down into something that people can understand. The physical model side is showing how the requirements are going to be implemented. Again, so brought to fruition, brought to code. Many systems analysts take a 4-step approach. So especially if you're walking into an existing system, you're going to look at, so again, you're going to do that whole fact-finding process, create a physical model of the current system, okay, so you'd sit down and sketch out what that system looks like in practice, develop a logical model that includes the processes, the data flows, and then from there, right, in addition to all of your other fact-finding techniques that you've used, you would then build a logical model of the new system and then a physical model of the new system. which is a really well-rounded way of understanding the current system, what its strengths and weaknesses are, building on those strengths and fixing those weaknesses in the new product. All right. Of course, that takes time. Time means money. But again, when you look at justification and cost-benefit analysis, it could result in positive benefits in the long run because you've taken the time to fully understand the system and sort of what some of its shortfalls are, and then bringing those in as an implementation consideration for the new system. All right, so we'll talk more about physical models as we get more toward the implementation phase, but they are mentioned in this chapter correlating to the logical models that we're building. So what questions do we have?
Pretty much done.
You get it? Good. All right, under content assignments in chapter 5, here's that PowerPoint, okay? So if you want to look to that PowerPoint, now remember that included in that PowerPoint are just screenshots, so don't think you're going to be able to just copy that and edit it. You're going to have to just take that screenshot, that single screenshot, and then build your own model in Word or Visio or whatever you're going to use to put into your document, okay? Because you're not going to be able to edit a screenshot, obviously. But those are good places to start when you're doing your context diagram and your diagram 0, okay? Those are good places to start when you're doing that. And again, start with that base function, and then depending on what other processes you've imagined for your system, just add them in. And don't get crippled by fear that you're doing it wrong or it's not correct. Just try, all things try, and then ask for feedback if you're getting kind of bogged down, okay? Okay? Let me see if I can show you something really quickly. Is everyone making progress on their projects, though? Fairly caught up, at least a week from here? Meaning? Okay, good. I like to hear that.
We're current.
Okay, good.
We're done. Gotta make it look better.
Hey, that can come last. Go away. Okay, this is what I mean for tasks 3 and 4, okay? So these would be your attributes, things like entry type, description, label would be the name, values and meanings, notes, anything like that, okay? So in addition to documenting your attributes, I want you to come up with a single example from the process, from your data models, okay, to include it like this. Does that make sense? So in addition to noting the attributes, you would also provide the attribute for a single entity and process that you've defined for your TIM system. Does that make sense to everybody? Okay. Tons of examples in the book, but I just wanted to give you a visual of that screenshot for what I'm talking about. This here is what's included in, I think it's Visual Analyst, but a case tool, okay? Again, you guys aren't using a case tool to document all this stuff, but I just want you to kind of go through that very simple practice of documenting what an entity is and a process, and detailing what data elements you would be collecting and storing for that entity or process in your data dictionary. Because that's what would be happening here. You use this case tool to document these various attributes. It would be saved in the data dictionary, and then as you go forth, if you have to make any edits, that will be done here as well, and that would result in this document, if you will, requirements document, that would be provided to your development team at the end of the design phase. Okay? Good? All right. All right, I'm not going to bog your brains. We've got 10 minutes, so 10 minutes to ask me questions, 10 minutes to get feedback on your work, 10 minutes to work on your work, or 10 minutes to peace out early and prepare for your next data dump of information in your next class, if you have that. Good?